I thought I might show you how I would use Excel to do energy analysis. So you might want to pause this for a moment and look at how I have it set up. What I tried to do is, well, I made up values for what the x and y velocity would be. You would get this from your Logger Pro analysis, and then I assumed that the height that it left the launcher would be 1 meter, that you would pull back the stretchy part, excuse me, 1.4 meters. I made up a number for the spring constant, and then I showed you what sorts of equations I'd be using. When it comes to the energy, that you don't, it's not a vector. In other words, it doesn't have direction. So it's not like you would solve for the horizontal kinetic energy and the vertical kinetic energy. So I have to use the Pythagorean theorem to figure out what is the total velocity at the launch. And so then I've set up this set of tables where these are the 5 different points at which I suggested that you would want to focus your attention. And of course, the first 2 are part of the launch, the next 2 are part of the flight, and the last one is the landing. And then I went ahead and put in zeros for each of the times that I knew that a particular energy storage would be 0. So in the preload, there's no energy initially, so working is going to have to take place, but I don't know how much work to put in there until I know how much I end up with. And so I'm going to go ahead and calculate what the spring constant, excuse me, what the energy stored in the spring is. So it's going to be equal to 1/2 times K, which is 100, and I could have set this up, probably should have set it up so that I just had numbers over here rather than with the units. That way I could have just clicked on it. And then that's going to be times the stretch squared, and the stretch is 1.4, and then I'll square it. And so energy is measured in joules, and so I know that the work has to be equal to whatever this value is. And then I know that the spring constant here, it's not spring constant, why do I keep saying that? That the energy stored in the spring is going to be carried down from the one above it. And then what I know is that the energy stored in the gravitational field is the mass, which is 0.25 kilograms, times the gravitational constant, the 9.8 meters per second, times the height, which I have said is 1 meter. But I didn't put equals, so it didn't know I was thinking of an equation. How about that? And then EK is equal to 0.5 or 1/2 m, which is 0.25, and then times the square of the velocity. And I happen to know that if I use the Pythagorean theorem with 10.6 meters per second, I get 15 meters per second. But you would want to calculate that. And so you notice that I have 113 joules here on the left, and over on this side I've got about 30 left. So I have plenty dissipated, and the way I would determine how much is dissipated is that I would say that it would be equal to what I started with minus what I ended up with, and then these values are what I start with down here.